All right, welcome back to The Explainer. Today we're diving into something completely fascinating, the spatialization of code, Minecraft, and digital archaeology. We're talking about a really wild intersection of computer science, gaming, and architectural preservation. So we're basically going to look right past the standard flat interface of your screen and examine how abstract logic actually takes on physical form. Think about it for a second. What if you could literally walk through a line of code? We typically think of computer programming as just flat, two-dimensional text, right? Just rigid syntax sitting there on the dark screen. But today, we're totally upending that notion. We're going to look at code as a physical, navigatable space. Section 1. The Spatialization of Code. Abstract Logic in 3D. So what does this actually mean? Well, this is where digital data literally emerges from the flat screen. Formally speaking, the spatialization of code is the process where abstract text-based programming logic gets translated into physical, three-dimensional geometry and architecture. We're talking about the complete collapse of language and space here, basically turning the text of computer programming into literal physical structures. Just think about the stark contrast between these two worlds. On one hand, you've got traditional code. It's 2D text, sequential lines, totally abstract. But then, compare that to spatialized code. We're talking 3D voxel blocks bound by actual physics, functioning as navigable masonry. The source material actually uses this brilliant masonry metaphor to contrast standard Java programming with Minecraft's tangible block-based execution. And this whole concept brilliantly illustrates where this all started. So Minecraft, as you probably know, is an independently developed Java-based video game. But to optimize file sizes and, protect their proprietary designs, the developers originally processed their code through an obfuscator called ProGuard. This basically replaced all the human-readable classes and variables with completely meaningless randomized characters. It was just an illegible binary. But because the game was obfuscated like this, the player-producer community was forced to step up. They reverse-engineered and collaboratively mapped the code themselves, which actually birthed this massive modding culture. To bypass that obfuscation barrier, modders built what's known as the Mod Coder Pack, or MCP. And the process was intense. First, they had to decompile the raw bytecode. Second, deobfuscate those randomized names. Third, they applied community-sourced, human-readable mappings just to make the code legible again. And finally, they had to re-obfuscate the mod of code so it could actually be safely injected back into the game engine. It was this massive, highly collaborative translation effort just to read the game's structural logic. Section 2. Redstone and Physical Architecture, Physical Computation. Now, an absolutely crucial point here is the intense mathematics running behind the scenes to make this physical grid possible. The game actually divides the world into 16 by 16 by 16 chunk sections. That's 4,096 blocks per section. To keep millions of those blocks loaded without completely caching your computer, the engine uses pallets to store block states super efficiently. This works alongside NBT double precision floating point vectors to track exactly where everything is in 3D space. It uses parallel processing and intense coordinate matrices to serialize the entire environment dynamically. And because the game engine handles these physical rules so rigorously, players can use Redstone, which is Minecraft's in-game circuitry. But listen, this isn't just a fun game mechanic. It physically translates computer programming into masonry-like structures. Logic gates aren't just abstract concepts here. They are literally constructed like brick walls that you can touch and walk around. Section 3. Rebuilding Pokemon in Minecraft. Code as Architecture. Okay, this next project is absolutely awe-inspiring. A creator actually rebuilt Pokemon Red entirely within the bounds of Minecraft. Picture this. You're standing in this massive VR-like stadium, looking at an emulated Game Boy screen. But here is the crazy part. If you fly behind that screen, you'll see that every single line of the original game's assembly code has been mapped directly into 3D space. The code logic is constructed as massive, floating arrays of blocks. You are literally bypassing the compiler so you can inspect the logic physically. There's this brilliant quote from the research documents that perfectly captures the feeling of this project. It says, "Being able to fly through a code landscape and reorganize blocks of it like masonry has been desirable in and of itself." The researcher actually compares this exact experience to the VR hacking scenes in the 1995 cyberpunk film Johnny Mnemonic. You're basically navigating a physical city of logic gates and data streams. But here's the catch. When you spatialize code like this, you also spatialize the errors. The source documentation talks about embracing the glitch. In older games like Pokemon Red,
glitches weren't just bad programming, right? They were basically rites of passage. So by rebuilding the game block by block, glitches and all, these software anomalies are treated as authentic historical ruins. They're the actual historical footprints of human interaction with the machine, preserved right there in physical space.
Section 4. The 2B2T Anarchy Server. Archiving Digital Chaos. 24 terabytes? Just let that number sink in for a second. That is the totally incomprehensible scale of the data secretly mapped and archived by a devoted team of Minecraft fans. So where exactly did this 24 terabytes come from? The infamous 2B2T server. This is a 16-year-old active anarchy server, meaning there are basically zero rules, no bans, and a complete anything-goes culture. It's a sprawling wasteland of griefed landscapes and the remnants of ruined bases. The archivists had to work incredibly carefully here, deploying secret bots to map the area. Why? Well, because it's a completely hostile environment. If the players had discovered this archivist bots, they would have actively hunted and destroyed them to protect their hidden bases. Let's walk through the chronological milestones of this intense digital excavation project. It's pretty wild. So in December 2024, they successfully mapped a 512,000 square block area of the overworld. By June 2025, they hit 100,000 blocks of the nether. In February 2026, 256,000 blocks of the end. And finally, by April 2026, they completed this massive 1 million square block area of the overworld. It was a multi-year, highly secretive undertaking that literally cost thousands of dollars and countless hours. Which brings us to Section 5, Archiving Digital Ruins, Preserving History. This fan-driven archiving, it's a monumental act of digital archaeology. As we're seeing with the emergence of the digital humanities, scholars are finally realizing that game files, procedural worlds, and massive sandboxes like Minecraft are actually legitimate cultural records. They're treating these digital spaces with the exact same reverence a traditional archaeologist would treat physical ruins. So what's the actual value of this archaeological record? Well, it's about preserving defunct source code and capturing the historical technical debt that developers left behind. It's about mapping large-scale community collaboration, the literal sweat of the brow from millions of users, and securing these artifacts against digital decay. Preserving these spaces captures human effort permanently within the substrate. Which leaves me with a final, kind of provocative thought for you to chew on as we wrap up this explainer. From the microscale of a single redstone logic gate, all the way to the macro reality of a 24 terabyte ruined landscape, what other digital ruins are waiting to be excavated? And was code always meant to be a physical space? Definitely something to think about the next time you boot up a game or write a line of code. Thank you so much for joining me on this journey today, and as always, keep questioning the interface.